Today we are starting our Chapter 6 opener and fair game review. By the end of, even to the start of today, you should already know how to define area, use formulas to find area of 2D shapes, and label area. So again, these are things you should already know, but we will spend one day today reviewing this skill. So, area is the amount of space inside an object. So, if we were to color in this object, that is our area, the area inside. To find area, there's 3 steps I'm looking for. Choose a formula, substitute the given values, solve, and actually I'm going to add on a 4th step, and label. So again, here are the main steps for finding area. Choose a formula, substitute, solve, label. Now this is very similar to evaluating expressions, which we've been practicing. Choose that formula, substitute, solve, label. Make sure you're writing this down, as these are the main steps for how to solve every problem today. This is your area handout with all of our formulas that we're going to be using today. So the formulas for area are, each shape has a different formula. So if you have a rectangle or square, it's area equals base times height. So you take the base of the rectangle, multiply by the height. Parallelogram actually has the same formula, which is base times height. Area equals base times height. Triangles are pretty close. We take area equals base times height divided by 2. Trapezoids are where things get a little bit harder. We take our height and we multiply it by the 2 bases added together, and then we divide it by 2. So height times base 1 plus base 2 divided by 2. Add those bases together, then multiply by our height, then divide it by 2. And circles, our area equals pi times radius squared. Making sure you're copying these formulas down into your area handout. They'll be used throughout today and tomorrow, and actually really all of this chapter. Our label for area is always units squared. So centimeters squared, inches squared, yards squared. And we square it because it is a 2-dimensional measurement. So we square that label or that answer. So whatever your unit is, miles, feet, inches, centimeters, units themselves, make sure you put a little floating 2 next to your label. Again, you should have written these formulas down. What we're going to do today is we're going to see examples of each one, and then you're going to try your own. So we're going to start with rectangles, squares, or parallelograms. We learned on our formula handout that all those formulas are the same for those 3 shapes. So I'm going to do this example first. First, to find the area, we use our formula, A equals base times height. Step number 1, write the formula. Step number 1, write the formula. Then we substitute. So instead of the letters that we know, we put the numbers. So we still don't know our A, so we just leave it as A equals. Our base is 3 and our height is 4. So you can see my substituting. I didn't just do that step in my head. You have to make sure that you show your substitution. And now I can solve and label. So area equals 3 times 4 is 12. My label is going to be meters squared. So I'm looking for all of those steps from you as well. Did you write the formula? Did you substitute? And did you solve and label? Go ahead and you try this your turn now. Again, all of this can fit right on that area handout. And here's the correct answer for the your turn. How'd you do? Did you first write the formula? Did you substitute in and show that you're multiplying 5 times 3? Then did you solve to get 15 with a label of meters squared? Let's go ahead and move on to triangles. First, I'm going to show this example here. Step number 1 is to write your formula. Our formula for triangles is area equals base times height divided by 2. Now I can substitute in. So I have area equals, my base is 24, times my height, which is 7, divided by 2. This guy right here, my diagonal part of my triangle, that's actually called the hypotenuse, and you'll learn about that next year. But this measurement, we don't actually need to find area. So they just threw it in there almost to throw you off a little bit. Now I can go ahead and do that multiplication math. So now I can use my calculator after I showed my work. And I do 24 times 7 divided by 2. That's going to give me an A equals 84 with the label inches squared. So again, you're looking for, did you show the formula? Did you show your substitution? And then did you solve and label? Go ahead and you try this your turn here. We'll pause the video while you work. And here's the correct answer for your turn. So not only am I looking for that answer of 6 centimeters squared, but I'm also looking for, did you show your formula? Did you substitute? Are you showing those skills? You cannot just type stuff into the calculator. I'm looking for the formula, the substitution, and the solve. The reason we show our formula is because in this chapter, our formulas are going to get a little bit longer. So it's important to be able to show it and then substitute in those numbers. Let's go ahead. Now we're going to move on to trapezoids. The trapezoid formula is a little bit longer. So I'll show it on our example here. Formula is area equals the height times the base 1 plus base 2. Then we can divide it by 2. So the first thing you do is write down the formula. You should do that right now. Next, we are going to substitute in. So we have our area equals, our height is 9 meters, times our base 1, which is 15, plus our base 2, which is 7, divided by 2. Now it doesn't really matter if you did 7 plus 15 or 15 plus 7, because addition can go back and forth. This next part here, we have to make sure we follow order of operations. So the first thing I'm going to do is start by adding inside the parentheses. So we have area equals 9 times 15 plus 7 is 22. Then I can divide by 2. Now that I have multiplication and division, those are on the same level of importance, I can just go ahead and type that into the calculator, and I end up getting 9 times 22 is 198. Divide that by 2, giving me 99. Don't forget a label, meters squared. So trapezoids, I have a little bit more work here because the formula is a little bit longer. The longer your formula gets, the longer the math is that you need to show. Go ahead and you try this your turn. We'll pause the video while you work. And here's the correct answer for this your turn. So how did you do? Did you show your formula? Did you show your substitution, your solve? Did you get the correct answer of 32.5? And did you label centimeters squared? Right, next we are going to move on to circles. As you can see, guys, the setup's the same. The only thing that changes is the formula you're using. So we're going to start with our example here. The formula for circles, if we look on our handout, says area equals pi times a radius squared. Now I can substitute in the information I know. Substitution, we have area equals, we learned last year that pi is really the number 3.14. So 3.14. We also learned last year that radius is from the center of the circle out to the side. And we have that in our example here. We are given our radius. Now, diameter is all the way across the circle. But our formula needs radius. So we only need half of the full length of our circle. We only need from the center all the way out. Okay, so here we have 3.14 times radius squared. Our radius is 7, so we have 7 squared here. Order of operations says you must start with your exponents. So I'm going to start by solving and say area equals 3.14 times 7 squared is 49. Again, you have to start with your exponent. And then I am ready to type in my answer and get area equals 3.14 times 49 is 153.86. Don't forget to label. We have inches squared. So again, the radius is only from the center of the circle all the way out. When you start this U try here, make sure you pay attention to what is the radius of that circle. We'll pause the video while you work. All right, and here's the correct answer for that one. All right, so the first step here was to solve or to show your formula. A equals pi r squared. My substitution, pi is always 3.14, so I plugged that in. My 5 here isn't in my question, but remember that radius is only from the center of the circle all the way out. So in my example, I'm given the diameter, which is all the way across. So half of that diameter is my radius, which would be 5. So I need to plug in that radius of 5. I start with my exponent. 5 squared is 25 times 25 by 3.14, giving me my answer of 78.5 centimeters squared. Right. Now that we have our basic 2D shapes, the next thing we're going to look at is composite figures. Composite figures are multiple shapes put together in one. So you're going to use multiple formulas to solve these composite figures. So we'll start by looking at this first example here. What you want to do is you want to really figure out what shapes am I even looking at. So what I see is I see a rectangle on top here. We're going to call this the blue rectangle. And then I also see a red rectangle down here at the bottom. Okay, so I'm just going to kind of color these in and give them a shape. So the first thing I'm personally going to start with, covered up my height there, I'm going to start with my red rectangle. The formula of a rectangle for area is area equals base times height. My base of that rectangle is 34 and my height is 8. So I have area equals 34 times 8. So the area of the red rectangle is 272. Now I can move on to the blue rectangle here. I'm going to put that over to the side. This is still a rectangle, so the formula is still area equals base times height. The base of my blue rectangle is 20. And the height is 12, so 20 times 12. So our area for the blue rectangle is 240. So what I do to figure out the area of the entire shape is I simply add them together. So I have 240 plus my 272 is going to give me an area of 512. Don't forget to label. This is going to be feet squared. So with composite figures, you really want to break them up into the 2 shapes or 3 shapes or 4 shapes that you see. Okay, they could have multiple shapes. You could even break them up differently than someone else, and that's totally okay. Go ahead and you try this one over on the right here. Now this isn't on your handout anymore, so you're going to want to try this in your notebook. We'll pause the video while you work. And here is the answer to the you try. All right, how'd you do on this shape here? First, I took my rectangle and I found the base times height. Then I took my triangle and I used the formula area equals base times height divided by 2. I got those 2 shapes, and then what I did is I added those 2 shapes together to get 216 centimeters squared. As you can see, I am still using my formulas. I am still substituting and I am still solving. Composite shapes are basically like 2 or 3 shapes put together into one. We're going to look at 2 more composite shapes today. And what I like to call these are level 2 because, well, one, we have 3 shapes now. And second, we have these things called semicircles. So I'm going to look at my first example here. And the first thing I see is 2 semicircles. But what I see is 2 semicircles really can make one full circle if I put them together with a diameter of 2 inches. So I'm going to start with that. I'm going to use my full circle formula. Area equals pi r squared. Pi, we know, is 3.14. My radius, if all the way across is 2, half of that is really going to be a 1 inch. So 1 squared. 1 squared is just 1. 1 times 3.14 is 3.14. So the area of those semicircles are 3.14. The next shape I see is a square here. So to find the area of this square, I'm going to do base times height. Both the base and the height have a length of 2, so 2 times 2. So our area of this rectangle is, or I'm sorry, this square is 4. Just like I did before, I'm going to take my 2 areas and I'm going to add them together. So the area of my circle plus the area of my square is going to give me an answer of 7.14 inches squared. So I did the exact same thing. I just had to make sure I'm using the correct formulas. So go ahead and you try this your turn right here. We'll pause the video while you work. And here's the correct answer to the your turn. So we can see here that the first thing I did is found the area of my circle. I have two semicircles, which if I pushed them together, I'd create a full circle. Then I found the area here of my rectangle. And I took those two answers and added them together. Again, we should have learned this information last year, so we should already know this. This is a quick review. There is some more practice if needed in the paper copy of today's notes.